Okay, the next concept that we will be looking in today's class, or the first today's class will be like method overloading. Okay, so what exactly is meant by method overloading and how to overload methods is what we'll be looking into today's class. So let me create a class and a package for it. So say new class, and here I say on dot easy learn java dot method overloading, method overloading concept, and the class name that I'm going to create is like employee. Okay, so employee is a class that I'm trying to create where I'll show a scenario of how you can overload different types of methods in it. Okay, or what exactly is meant by method overloading, that's what we will see here. Okay, let me start with a simple example. So in an employee class, let us assume that we do have a scenario where I want to calculate the salary of an employee. So to calculate the salary of an employee, let us assume that I do have certain properties or parameters that I can take into consideration. So the simplest example, or let me start with a simple example saying that I know an employee ID and for which I want to calculate the salary of an employee. Okay, so all I do is like I say public double double uh, EMP salary, or I say calculate EMP ECAPS salary S caps. See the naming convention of the method. So to this method, all I do is like I would like to pass an employee ID. Okay, so I say int EMP ID. I want to pass that, and this is out the employee salary is. Just maybe I just want to print some values. Okay, so a simple method with a return type of double. So now in different class, like in a class demo, all I do is like I would like to create an object for employee and would like to call that method. So I say employee emp equal to emp dot calculate employee salary 1. So passing some employee ID. Okay, 1. And if I write this out, or I will not write this out, but it's just if I execute this program, this calculate employee salary will call the method which is present in this employee class, and will print this output, and 5,000 will be returned for you. Okay, so if I run this, so the employee salary is 5,000 is what is being printed. See this method. Okay, I just wrote this out so that you can understand some information or something which is being printed from that method. Okay, so in real time there might be methods where all the logic which you write here might be dynamic based on different scenarios. So tomorrow there might be a criteria where you want to calculate the salary for a contractor. Okay, so calculate employee salary. So in that scenario you might say like the employee ID and string EMP type. Okay, so in that scenario you might have different conditions. I'm just this is a sample scenario which I want to show. If EMP type dot equals FT full-time employee. Okay, if he is a full-time employee, then say that the salary or whatever logic I write at line number 13 or in that scenario will depend on some scenarios. Like if it is a full-time employee, take all the parameters, take few parameters into consideration and calculate. So whatever I write at line number 13 is like some logic. in real time. And if emp type dot equals contractor, then write your own logic which will say that okay, based on these scenarios you will calculate an employee salary, and for a contractor the salary will be 4,000. Okay, if the employee type dot equals part-time part-time employee, then say that for that guy it might be something else, so it will be like part-time employee $2,000 like that. Else employee type is some error message will print or whatever. Okay, employee type is undefined or whatever you say. Or maybe I say that for every other person like the employee, the salary will be $1,000. Okay, so what I say is if it is a full-time employee, return 5,000. If it is a contractor, return 4,000 back to the caller. Okay, some logic I wrote. Now I will be writing one more way for calculating the salary for an employee. So in this scenario, what I will do is I will try to pass a few more parameters like employee ID, employee type, and then string emp designation. So based on the designation I want to calculate, saying that if the designation is above an employee, like an engineer, the bonus will be like $100 more. If he is a CEO, $500 more bonus. Like that means I want to calculate. So I'm not interested in understanding the internal logic. Okay, so return. Okay, I'm not interested in understanding all this internal logic, whatever I wrote. But my main idea to write these methods is to make you understand that hey, in a class there is a method called calculate EMP salary, which is written thrice. It's not only thrice, it can be written n number of times with some criteria. For that n number of times to write it, see if I write the exact same method again, it will start complaining saying that hey, this is a duplicate method, you cannot again duplicate, you cannot rewrite it. Okay, duplicate method it shows. So in what scenarios you can come to a conclusion that you can write the same method in a different way in the same class? The concept is the method name can be same, but the input arguments, whatever highlighted part is nothing but the input arguments for the method. Okay, so the input arguments for the for the method defined at line number 11 is different from the method arguments which are defined at line number 5, and which are different from the method which has the parameter arguments at line number 27. And let me write one more method to avoid a little bit of confusion. So many people might think that okay, one parameter here, two parameter here, and the other one it has three parameters. It's not like that. All you need to understand is for the first one has a one parameter of type int. So so, so what is this? Both methods at line number 5 and line number 10 have the exact same name but with different input arguments. Okay, so this concept is called as method overloading. Method overloading means same method in the same class being repeated with different input arguments. The input arguments basically is called as method signature also. So method overloading is considered, in simple terms, method overloading is considered as same method in the same class with the different method signatures. Method signatures means input arguments. Okay, so that is considered as method overloading in Java. Okay, so now if I want to calculate the salary of an employee by passing an ID, I will be calling a method at line number 5. But if suppose I do have some requirement where the company says that I know the employee ID and I know the employee type. There are only two parameters that I know. So calculate the salary based on these two parameters. Then in that scenario, you will call a method at line number 15. But if the company says that, hey, I don't have uh, an employee ID, I only have a designation, then you will use the method at line number 10. If the company says that I have an employee ID, employee type and a designation, then we will be using this method. So what is happening? Same method is able to uh, give different types of business, so gives solution to different business requirements. How you want to calculate employee salary based on what scenarios? So here I know employee ID, so I did this. If I know employee ID and type, then I say emp dot calculate. So what all I know? ID I know and the type I know. Then I will call this method. Calculate employee salary. The employee ID is 2 and the employee type is CT for contract. Or if I know only the designation, I say emp dot. Do I have a method which will calculate the salary based on only designation? Yes, I do have, which is nothing but the second method. So what is the designation? Some random name. Okay, engineer. Now, do I have any other parameters? Yes. In the current scenario, I do have different parameters like I know the ID, I know the employee type, I know the designation. Do I have a method? Yes, I do have it. So the employee type is full time and the designation I say is a CEO. Okay, like that. So same method with different signatures in the same class is considered as method overloading. Any doubts or any questions? Okay, awesome, very good. Now with this understanding, before I proceed to the next topic, I would like to ask a question to everyone, so please answer this question. Okay, can a constructor be overloaded? Awesome, the answer is yes. Why? Because if you see a constructor in our previous class, if we just go back and see the concept of a constructor, in the constructor we saw like I do have a constructor which does not take any parameters as input, which is nothing but a default constructor, and a constructor which can take in different types of arguments as input, right? Which means the same name, constructor has the same name here but with different arguments or different signatures. Okay, so signature is nothing but the type of arguments that you can pass. Okay, so the answer is yes, the constructors can also be overloaded. Okay, method overloading, maybe we already saw the concept of constructor, so in the constructor itself I will be showing you a quick example here. So I say uh, class engine. So in this engine, I'll be creating some parameters like private int ID, private string company, private double lifespan, okay, something lifespan, okay, some parameters I created. So here I can create a constructor. See how I can do that. So I say public. Let me before this, let me generate the getters and setters. So generate getters and setters for all these three. Say okay, done. Control Shift F to format the code. Now here let me write some constructors, or let me overload constructors. So public engine, this is a default constructor, and now let me say public engine, and I say, let me say int some id, this dot id equal to id, some property that I'm passing, or I can say public engine int id double lifespan. Let's say this dot id equal to id, this dot is equal to lifespan. Okay, so did you notice here the same constructor is being overloaded with different types of parameters. Okay, so let me just write one last type of constructor. So I say public engine string str, this dot company equal to str. Okay, so here this constructor takes only one argument, even this one takes only one argument, but the difference is this specific id is of type int, but this specific parameter is of type string. So that's how the signature differs, and this is considered as constructor overloading. So during object creation, if you want to call this constructor, you can say engine e equal to new engine. If you want to call this engine e equal to new engine of 5, if you want to call this, you can say engine e equal to new engine of 4. Like that, you can pass in different types of parameters and you can call them. Okay, any doubts, any questions? At line number 23, okay, let me take the question. In line number 23, even this is not given, it is fine, right? 23. Okay, sorry, I did not get your question. Can you unmute and ask the question?
Yeah, as the argument name be given as a
Okay, one
lifespan.
second. I think my volume is
So
way too low. So let me just increase the volume. Yeah, can you go ahead with your question, Sai, once again?
yeah, in that method actually we gave the argument name as lifespan, right? So if I give it as a ls equal to lifespan, that is fine, right?
LS equal
So
to
let
like, okay,
this
I got
dot.
you.
Uh,
This is what you mean to say, right?
yes, yes.
Okay. Yeah, the answer is absolutely right. The only reason why I'm writing this is, in general, if you try to use the default behavior of creating constructor using Eclipse, then what Eclipse does is, it does like this. It if I want to pass this ID, it places ID here, and then it writes this dot ID equal to ID. Why? Because if I write as you said like ID equal to ID is what you
Yeah,
want me to write. If I write this,
yeah, yeah. In
it
this,
means that this specific ID is being assigned to the same ID again. That is what happens. Since the naming convention at line number 5 exactly matches with the naming convention at line number 13. Because of that problem, to eliminate that, the Eclipse says this dot, which means the current object ID is equal to the property that you are passing in this one. Okay, but here why line number 23 is always valid, because here instead of writing ls I renamed it to lifespan. So since it is lifespan, here when I say ls, it understands that okay, this ls means this variable. So ls is equal to lifespan. That's how it matches and it is good in this scenario. But in this scenario,
Yeah, yeah.
removing this is not a valid thing. Right? I hope this makes clear, right?
Yes, yes.
Okay, awesome. Okay, but for time being, like I would like to use this so that it will be clearly understandable even in the future if you rename lifespan to ls. Okay, yeah, that's good. Now, if this concept is clear, let me go to the next step. Next step means the same old concept, one step ahead in that, or one thing that you need to understand is whenever you are creating a method and trying to overload it, okay, overload, you are making sure that the signature is different. Okay, so let me duplicate it. I know that it will cause an error since it will start complaining saying the duplicate method. I still understand, but most of the people get confused at this point. So when I say the method signature must be different, okay, sometimes people will ask like, hey, does it matter if I change the return type? Okay, so return type is different from the signature. Return type is never ever considered as a part of signature. So when I say signature must be different, it means the input arguments must be different. So my next point is, will it make any difference or can I resolve the error at line number 10 by changing the return type? The answer is no. Method overloading will never ever consider a return type. Okay, so which means that my question is, if I make or if I change the highlighted double to int, okay, if I change it to int, will the error be resolved? Okay, so Sheikh, I'll come to your question. So the answer is, for this int and this double, it means since they are written types, they are never ever a part of method overloading concept. So even if you change this, the compiler still complains saying that this exactly match with line number 5. So return type is never considered in method overloading concept. That is the next point that I want to explain here. Clear? Okay. So let me take a question here. So Sheikh has asked, like, what exactly is the use of return here, as we are already printing the value 5000. Okay. So that's what Sheikh, like, all I want you to understand in this method is, don't see what we have written internally inside the method. All I want you to do is understand the concept of method overloading only, not the internal logic. But to answer your question, I wrote line number 6 or line number 22 or 25 just to make sure that whenever you execute a program at a demo.java, it will print that statement and you can understand, okay, this statement is what I have written in calculate EMP salary at line number 5, which means that method is being called. So in order to show you an output that that method is being called, I wrote that. But ideally, all I can say is like the employee salary is being calculated like this. I can say, okay, and I can return 5000. Once I return 5000, this is where I'm calling, right? So I can say I'm getting a double output, double sal equal to, then here I write this is out. The employee salary is, it is present in the output parameter called sal. Okay, I will do this. So if I run this program, so the first one is the employee salary is being calculated, which means that this sysout is printed. So you can clearly understand that, okay, this method is already called. So now from here 5000 is being returned back. So the employee salary is 5,000 is what is being printed for you. So just for your understanding purpose, I'm writing all this out like 5,000, 4,000, or something like that. Okay. Does that answer your question? Okay. So okay, let me answer that question straight. So return type has no special functionality. Okay. So return type has a special functionality. Why? What exactly is that? If I say double, I can say 50,000 dot 67 cents, $5,000 dot 67 cents. But if I say int, I cannot do that specific return type. Why? Because that is double. I cannot do that. So I can say 5,000 only. But ideally, what happens is the actual logic. See, if you're working in a company called ABC company, to calculate a salary, it has a big method. In that method, it will take the number of days that you came, and if you're a contractor, it will try to see what is the billing rate, and is there any bonus for you, are there any extra hours. Like that, the company will take a lot of values into consideration, and they will write some 100 lines of, just assuming, they will write some 100 lines of code, calculate your salary, and that salary will be returned back for you. In this concept, my intention is not to explain how to calculate a salary. My intention is to explain how you can write the same method with different types of input arguments, and with based on those arguments how to calculate the salary. So if I write all these 100 lines here, and if I get an output called 2000, then I will be returning 2000 there. If I get an output called 5,000, I will return 5,000 here. So return type has something to do with the type of method that I'm trying to write. Clear? Or still have questions? Okay, no problem. That's good that you get your doubts clarified, everyone. Okay, thank you. So before I proceed to the next topic, let me just reconclude all the scenarios that we understood. All the scenarios means just two basic scenarios. The first scenario is, whenever I say method overloading, it means same method, okay, with different method signatures in the same class is considered as method overloading. Constructor can also be overloaded. And the second point, in method overloading scenario, the return type of a method is never taken into consideration. Okay, these are the 2 points. So I hope that the method overloading concept is clear. So let me go back to the next concept, that is nothing but inheritance concept in Java. Okay. Okay. One of the most important concepts. So just make sure that you understand this concept well. So let me create a class called savings account. So in savings account, I will have a method called public double get account balance. Okay. So see, I'm just writing one return statement at line number 6. Okay. So I'm just writing one return statement at line number 6. Understand that in a real-time scenario, you will write some n number of lines. Okay. Whatever logic you write. So you will write that logic and you will send back that output to the user. But for time being, I'm just hard coding the output to 100. Okay, but in real time scenario, person 1 account balance will be different from person two's account balance, or it might be same or different. Sometimes everyone might have $100, sometimes people will have 100, 200, 300, like that, different account balances. So again, here my intention is not to explain the internal logic of a method. Okay, so I just wrote a random value called return 100. Then the next thing is public double calculate interest, or I say get interest rate. Get account balance, maybe I can pass an ID, string ACC ID, account ID. Here I say return. So 2 stands for 2%. Maybe let us assume the 2 stands for 2%. So now there are two methods in savings account. One is like get account balance by passing the account ID, then get interest rate. So since this is savings account, I say the output that I want to return is like for this account it will be 2%. Okay. Now let me create one more class like checkings account. Okay. Let us assume that checkings account also has the same methods. Okay. Why? Because even for a checking account also, you know, right? We want to get the balance that is present in our checkings account, and also we want to know like if there is any interest rate for this checkings account. That's what we will see. So now when I say let me say that you have different accounts like a transaction account you have, or a home loan account you have, or like that, based on different scenarios you might have different methods: a car loan account, second car loan account, home loan account. Okay, like that you can have different types of accounts present for a user. But for each and every account, I hope you understand that getting an account balance and calculating the interest like this, there might be some common set of functionalities which are common across all the accounts. Yes or no? Very good. So
Yes.
yeah, that's good. So the next scenario that we're going to understand here is code reusability. How can I reuse a code, means which means like how can I create or write a code at one location, and how can the code written at one single location can be reused across multiple classes. Okay, so how can I achieve that? Yes, we can achieve it in Java using one of the object oriented programming principles, that is nothing but inheritance. So inheritance helps us to do achieve this. So let us see how we can achieve that. So let me create a simple class again called account. Okay, so I've created a class called account, and for time being I know both the methods which are present in savings account and checkings account are those methods are common across every account class. So what I say, I will try to write those two methods in the account class. Understand the concept very carefully. So I'm writing the two methods in one class. Now let me go to the savings account. I will remove everything, and even in checkings account I will remove everything. Now before I proceed, just understand that there are three classes here. One is an account which has two methods, and checking account which has zero methods, and savings account which has zero methods. Now, when I say I want to inherit, it means that I want to get the features from one class to the other class. So what is our scenario? Our scenario is to make sure that I do have a class called account which will have all the common features, and every other class will extend from the parent class. So for that what I say is savings account. I will use a keyword here. A keyword is a predefined word in Java with some special meaning. So I will use a keyword called extends and I say account. From where I want to get the features. I want to get the features from a class called account. Okay. So now all I did is I wrote extends account is what I have written here, and here okay, let me do one quick uh, uh, test here. Okay, so two classes, savings account, checkings account with 0 methods, and one more class called account with 2 methods. Well and good. Now what I say is let me create a demo class. So in this demo class, let me quickly create one simple scenario like account class scenario. Account ACC equal to new account. Okay, everyone please answer this question. How many methods I can call using the variable ACC? Very good. I can call two methods using that variable ACC dot. I can say get account balance and I can pass an account ID as ABC123 is my account ID. It is but a string. And then there is one more method I can call like ACC dot get interest rate. Okay. So for time being, let me run. So if I run it, everything is executed and everything is good. Let me write some sysout statements so that they can print that sysout confirming that those methods are called. Sysout. So I say get account balance in account class is called sysout get interest rate is called. Okay. Just some methods I have written or some sysouts. So now if I execute the same thing again, it shows get account balance method in account class is called and get interest rate in account class is called. Well and good. Everything is good. Now answer this question also please. I am creating an object for savings account. Savings account SACC equal to new savings account. Now how many methods that I can call using the variable SACC? 2 good, 2 good, 0 good, 2 good. So I want everyone to notice that savings account is a class with 0 methods in it. So in the current scenario we can never call any method. Okay, so when I say any method, there is a clause again. I will explain that later, but for time being, we can never call the get account balance and get interest rate. This is what I am trying to explain here. So since this method doesn't have any methods, I cannot call any method using that variable. Now let me create one more object for checkings account and tell me how many methods I can call using that variable. Okay, I said checkings account EACC equal to new checkings account. Okay, yeah, gotcha. We did not extend it. We'll go to that concept. Okay. So now what is the answer for this? How many methods I can call using CACC variable? Okay, that's good. So the answer is 0. So checkings account is a class again which did not extend anything from anywhere. So right now I don't have any method, any custom method that I have written that I can call. So the answer is 0 again. Okay. Now before I go to the next scenario, I would like to explain the same old simple scenario that everyone knows. ACC is a reference variable of type account ACC is pointing to an account object. The most important lines for understanding the concept of polymorphism, which we will see in this example later. Okay, then SACC is a reference variable of type savings account. SACC is pointing to a savings object in the memory. Understand the importance of this. That is the reason why I'm stressing so much on these things, even though they might look very easy for you to understand right now. CACC is a reference variable of type checking account. CACC is pointing to a checkings account object in the. Any doubts in these comments that I have written? Okay, now going back to the concept of inheritance. So now what I want to do here is I want to make sure that since there is a location like account.java, not a location, there is a class called account.java which has all the reusable methods. What are all the reusable methods? Get account balance, get interest rate. This can be reused in every child class out there or in every class out there. So I want to say I want to get the features from the account class. I say extends account. Okay, just two simple things that I did. And checking account. So sorry, once again, sorry, let me just go back and show you before I do that. Why? Because it just gives you a confidence that yes, it is not there. So here when I say SACC dot, we can never ever see anything called get account balance or get interest rate. Do you see any of those two methods here? No, the answer is no. Now with just a simple change of extends account, okay, with just a simple change of extends account, let me go back to demo.java and let me do control space. Did you notice here just it shows get account balance and get interest rate, two methods it is showing additionally after I write extends account. The same is the case when I say CACC dot checkings account. Right now checkings account is not extending anything. So since checking account is not extending anything, I don't see a method called get account balance or get interest rate. But here when I come back and say extends account, then what I can, when I do control space, I can see get account balance and get interest rate in addition to all other things which are being shown here. So what is happening in this scenario when I say extends? When I say extends, it means the current class, which is nothing but the savings account, is inheriting or extending or getting all the features from the account class, which means in this current context the account class has become the parent class and the savings account has become the child class in the hierarchy. So who is inheriting from whom? The savings account class is inheriting from the account class. In this scenario, checkings account class is inheriting from the account class. So what is happening in this scenario? You are able to inherit these two methods into these two classes. Tomorrow, if you have one more account called some transaction account class. In that transaction account class, if you say extends account, so even in the transaction account class also, you will be able to get all these features. Okay, so now what is happening? You are trying to write all the common functionalities at one location called the parent, and you are telling all the children to reuse the same set of code instead of duplicating the code in every class. So code reusability is what you achieve mainly because of this inheritance concept. So instead of you trying to write everywhere, you write it at one common location, define all the common methods and place it in the parent class. Okay, is this concept clear till this point, like what you are trying to achieve because of inheritance? Okay, very good. Now going back to demo.java, since I'm extending, I'm able to call the methods. So what I say, sac dot get account balance. Okay, one quick question thing, or else maybe let me explain that. See here, when I say sac.getAccountBalance, getAccountBalance is a public method. The method name is getAccountBalance, and this method is taking an argument of type string. Okay, and it returns a value double to you. The input is string and the output is double, and in which class the getAccountBalance method is present. It is present in the account class. Ideally, we don't have a method in savings account. It is from the account class. So I want every one of you to understand the scenario. And the next is sac object dot get interest rate. Same thing, public method get interest rate, which is not taking anything as input, but which will give you back a double value as output, and it is also present in the account class. Okay, so I'm not repeating the same stuff again, re-explaining, but it's the same concept with checking the account also. Get account balance, same from the account class. Get interest rate. Okay, so now you are able to reuse the code. Let me write some sysout statements so that they will print some space in between the outputs. So see here, different sets of inputs, outputs. The first set of output is when I try to call account object dot. The second set of output is for when I call savings account object dot. The third set of input is when I call checkings account object dot. Okay, so like that, three times they are being called, but all are present in the account dot java class. So did everyone understand the concept of inheritance and how to reuse the code? And the last thing is how to call a method even though if it is not present in the current class. Ideally, you might think, how can I call get account balance and get interest rate when it is not present in account class? Sorry, in savings account class. Yes, those two methods are not present in the savings account class, but still, since you are extending account class, which means you are inheriting all the properties of the account class. And again, when I say all the properties, for time being, let us assume all, but there are again restrictions, which means like if you have some private methods, you can never ever inherit a private method. But right now I'm talking about a high level picture of at a public standpoint. Okay, public access standpoint. So is everyone clear till this concept? Okay, yeah, that's good. So now going back to the next level. In this scenario, the first step that we understood is like, if suppose, okay, I'm just quoting a scenario, if suppose there are 10 common functionalities in the account class. So all the 10 common functionalities I need not duplicate in all my child classes which extend account. Okay, which extend account. Now, in the next scenario, let us assume that out of those 10 common functionalities, let me take or let me pinpoint one common functionality like interest rate. Okay, get interest rate. Let us assume that the bank says that, hey, if you save money in savings account, then for 6 months, then you will get an interest of 3%. And if you save the money in checkings account, it will be means how much ever you save in checkings account and how long you save. I don't bother. All I do is I give only 2% interest rate. That is what the bank says. So what is the bank telling? Hey, savings account also has the interest rate method. Checkings account also has the interest rate. But in the current season, like maybe during festival season or during Christmas season, the bank might say that, okay, if you save money throughout this Christmas, from this Christmas to next Christmas in my bank for a period of 1 year, and if you save more than $1,000, I will give you an interest rate of 3%, which means what is that you are trying to understand here? Savings account also has the same method, but it wants to have a different functionality, right? So what is the common functionality every time it gets? It gets the common functionality that 2% is the interest rate. But right now, there is a change in the functionality in savings account. But is there a change for checkings account? No. Why? Because the bank is not interested in giving any interest for the checkings account interest rate. So I don't bother about checkings account. All I worry about is savings account. So in the savings account scenario, let me write a method and let me explain a concept of method overriding. Okay. Just now we understood a concept. See here, I have highlighted a package name, which is nothing but method overloading. So now I will explain the next concept, which is nothing but method overriding. Don't get confused. Remember one concept, the other concept you will automatically get it. Okay. So what I do is customizing the business logic for Christmas season. Okay. And the interest rate would be 2.5. Let us assume that instead of 2, the bank wants to do 2.5% interest rate. Okay. Now get interest rate in savings account class is called. So one quick reason. Tell me why or tell me one answer. Did I duplicate the code in savings account? Okay. Think before you answer. So the question that I am asking is, I do have a get interest rate in account, and again I am writing a get interest rate in savings account. Now my question is, am I duplicating the logic here? Is my question. Okay. So Ravi or Sandeep or anyone, can you tell me why you said that it is a duplication, duplicating the code again here? So logic is not same, so no duplication. Okay, my bad. Then when you said yes, I thought that you are you're telling that the method is being duplicated. Okay, or the logic is being duplicated. The answer is like the logic is not being duplicated. We are rewriting the same method. Okay, yeah, that's good. Yeah. discuss. So we are rewriting the same method again in the child class, but we are changing the logic that we want to write in the child class. So this concept is called method overriding. Okay, method overriding. Now, a simple scenario here is, if I want to implement the exact same logic which is present in account.java, if I want to implement the same logic, I will never ever override that method. Why I will override a method? Why? Because I want the same functionality called get interest rate, but with a different logic now. What is the logic? The logic is giving 2.5 interest rate if the customer has stored more than $1,000, if the customer has stored the $1,000 from Christmas to Christmas, from this year to next year Christmas, like that, it's a different business logic that I want to write here. So since I want to customize a logic, that is the reason why I am rewriting a method. Now the concept of method overriding is, okay, before I explain method overriding, one last time let's go back to method overloading and understand this concept. Method overloading, the most important key point in method overloading is it is done in the same class. Okay, method overloading is done in the same class. So in the same class you will repeat the method with different signatures. Okay, the main important thing is in the same class. But in method overriding there will be two classes. Okay, one is a parent class and one is a child class. In method overriding you will talk about the same method, exactly the same method, but in two different classes. One is the parent and the other is child. And you will say that if I want to change the behavior of how exactly the method behaves, then I will change it in the child class by overriding the parent class method. Okay, so sometimes people will think also like rewriting. Okay, again writing the same method, but what is the use of it? Because we change the logic. Okay, overriding the same method in the child class and implementing a customized logic in the child class. That is the concept of method overriding. Is this concept clear to everyone? Why we override and what is method overriding? Okay, awesome. And the next difference I want to talk about between overloading and overriding again. The first difference and the most important difference we understood is method overloading is only in one class, but overriding we understood that it is in different classes, we understood. And then in overloading we say like the signature differs from method to method. Okay, in method overloading I'm talking about, the signature differs from method to method, but in overriding it's the exactly the print, and means it means exactly the same method you will be writing in the parent and you will be writing in the child. Okay, so when I say exactly the same method, again there are some clauses there, but let's not worry about the clauses for now. Just understand that there is nothing that you need to change. You need to write the exact same syntax which looks in the parent, the same thing that you need to rewrite in the child also. So it means everything looks the same. Okay, that is the concept of method overriding here. Now if this concept is clear, now going back to the, yeah, that's what I told Sai. It's exactly the same thing. We will never ever change anything. That's what you need to understand for time being. Okay, yeah, that's good. Now the next concept, I go back to demo.java, and the one thing that I want to stress upon here in this current context is line number 18 only, 1 8. Okay, line number 18 only. In the previous context, if I execute, see, let me do one thing. This is the output for the previous scenario. Let me copy that output into a notepad. Okay, let me copy it into a notepad, and now let me rerun it once again. Now I'm going to rerun it once again and copy the same old output and paste it here. Something which you need to notice here is the first two lines and the first two lines exactly match the same, so I'm deleting those things. Okay, the last two lines and the last two lines exactly match, so I'm removing those two also. Now all you need to understand here is, see here, get account balance in account class is called, that is same, and this is also same. So I'm removing these lines also, this one and this one. So which means that there is a different type of output which was generated for line number 18 alone. For this line number 18, there is a different type of output which is generated. Why that different type of output is generated? Why? Because in the current context, when I say get interest rate, okay, answer this question. Where is this method present, get interest rate? Is it in account class or is it in savings account class? The get interest rate is very good team. It is present in the savings account class. That is the reason why the savings account class method is being called. That is the reason why this is the output that is being printed. Okay. Now everyone notice the change that I am making here and answer the question. So I am removing this method. Okay, I'm removing that method. Let me go back to demo.java and ask the same question again. In which class the get interest rate is present now? Account class. Okay, don't say ACNT or anything. Just say account, ACCOUNT account. So that's, yeah, or the parent class. Well and good. Okay, now the same question back again. I made some changes and I'm going back to demo.java asking the same question again. In which class the get interest rate is present? What is the answer? Savings account. Very good. Okay, so based on this scenario, if you are understand the scenario. Let's understand that line number 17 get account balance is not present in savings account, it is present in account. So when I execute line number 17, it calls the parent class method, but at line number 18 it will never ever call the parent class method. It will call the method in the savings account itself. Okay, now is it clear to everyone, like which method will be called? Is it the parent or the child, and how to decide upon that which methods will be called? Okay, yes, very good. Now taking this concept to the next level, or the most important concept, like polymorphism. Okay, so okay, let me add one more scenario before I go to polymorphism. It's like I create a class called special savings account, which extends which extends savings account. Okay, understand the scenario. I do have a class called savings account, and that savings account, I am saying that I am making that as a parent to special savings account class. Now, I want everyone of you to think before you answer and answer this question. Everyone must and should answer this. I say special savings account equal to new special savings account. Now my question is, how many methods that I can call using SSACC? Using this, how many methods I can call? Two methods is what someone will said, and what about others? Everyone make it try, even if it's right or wrong. Three methods is what someone said, and yeah, someone has asked a question like what class it is trying to extend. It is trying to extend savings account class. Two. Okay. So whatever savings account class has now. Okay, Adip, I just want the number. 1, 2, 3, 0, 4, 5. What is the number?
I don't know how many savings has, but since everybody's saying two, I guess I'm gonna say two too.
Don't say that. See, since you're following the class, you should be able to understand how many methods the class has till by this point. Okay. So let me explain this concept by writing the method here. The answer is 2. Why 2? Why? Because see here, the simple concept in hierarchy or inheritance. Special savings account is a child class for savings account. How many methods a savings account has? So if you go back to savings account, you might see that there is only one method is present in savings. But did you notice that savings account is inheriting from some other class called account, which means account class methods will be inherited to savings account, and those methods will again be inherited to special savings account. So in account we do have an additional method called get account balance, and it means the get account balance from the account class and the get interest rate from the savings account class will be inherited to special savings account class. Okay, so now I say SSACC dot, and the most important concept, see here, when I say get account balance, see here, it is a public method get account balance which is taking type string, and it returns double, and it is present in the account class. How a special savings account is getting a method which is present in the account class? Why? Because special savings account parent is savings account and savings account parent is account. So that is the reason why uh, this special savings account is also inheriting this method from the account class. Java allows multi-level inheritance. It means your grandparents giving the features to your parents and your parents trying to give the features to you, which means you are internally inheriting the features from your grandparents also in the hierarchy. So on top of you, your parents, on top of your parents, again your grandparents. So that is multi-level inheritance which is allowed in Java. Don't confuse multi-level with multiple. Multiple is never ever allowed in Java. We'll see that with an example. But right now, special savings account scenario is a multi-level. Okay, so that's one very important concept. Now I see here DEF. Okay, so this method is from the account class. Let's see again one more very important concept. Dot get interest rate. See, when I say get interest rate, this is a public method get interest rate which is not taking anything as input, but it is giving you, sorry, but it is giving you a double value as output, and it is present in the savings account. So many people might get a doubt here saying that, hey, get interest rate is present at two locations. One is in account.java and the second one is in savings account.java. So the next question that comes to many people's mind is like, which method will be inherited to special savings account? The answer is the method which is present in the immediate hierarchy, which means when I go to special savings account, it has an immediate parent as savings account. Now if I have a savings account and in that if I have a get interest rate, only this method will be inherited. The account class get interest rate will not be inherited. Why? Because whenever you have the same method both in the child and in the parent, okay, whenever you have the same method in the child and the parent, it means when you are overriding a method, overriding will hide the parent class method in the current class. So what is it doing? The get interest rate which is present in the savings account will hide the get interest rate in the account class. So the special savings account can only see the get interest rate in its immediate parent, which is savings account. That is the reason why in demo.java, when I say get account balance, since get account balance is not present in the immediate parent, it goes to the next higher level and it figures out that get account balance is present in the account class, but this get interest rate is present in the immediate hierarchy. So that is the reason why get interest rate will be inherited from the account class. Savings account class. Okay. Okay, is that concept clear to everyone? Very good. So this is the concept of multi-level inheritance in Java, not multiple. Okay. So now going back to the next concept of polymorphism, and this is the most easiest concept if you understand, and the most confusing concept if you don't understand. Okay. So let me know if you don't understand the next concept, polymorphism. So again, taking the same old example of account, checking account, savings account. So now, what is the meaning of, in general, I'm not talking about a Java perspective, what is the meaning of polymorphism? Polymorphism means, maybe you might have understood that it means like something which can exist in different forms. Okay, like if you remember the first classes, yeah, good side. If you remember the first initial classes, we understood that polymorphism means like an example of a carbon compound which can exist in different forms, right? Yeah, very good. So let's take the same example and try to see how a variable in Java can exist in different forms. Okay, and for that, let me create one more class like test.java, and let me copy the same old methods. Okay, whatever I write in demo.java is what I am copying here and again rewriting. Control Shift F to format the code. Okay, everything is good. Now see here, I'm not interested in all these method calls right now. We will write it later. And just let me write the SSACC is reference variable of type special, sorry, special savings account, and SSACC is pointing to a special savings account object in the memory. Okay, this is what our simple understanding is, right? Now I will make few changes here and I will try to restructure the same old comments that I have written. Okay, so now see here, I say I'm creating an object for an account class again, account 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 equal to new account. Okay, so now what is that account? So account is a reference variable of type account, and account is pointing to an account object in the memory. Okay, so now we don't need this. So let me create a memory location. So in this memory location, I'm creating something called as so this is new account, and right now what is the context that I'm talking about? A reference variable called account. So this account reference variable is pointing to this object in the memory. Okay, so till now I never explained, till now in this example I did not even start explaining the concept of polymorphism, but just I explained a simple scenario, account equal to new account. Okay, now understand here. The next concept that I'm trying to write here is, next statement that I'm trying to write here is account equal to new account. So before I ask a question, let me write one more thing here. So let us assume that this new account is at location called 2000, and at present account class is pointing to 2000 memory location. Okay, in the current scenario, based on line number 25 only, for just for your understanding, it is referring to 2000 memory location. Okay, now my next question, what will account reference variable point to at line number 26? Different location. Good team. It is not the same old 2000 location. Someone just wrote 2000. It's not 2000. Observe here team. At line number 26, I'm again saying new account. Okay. I'm again saying new account, which means give me a new memory location. So it will point to some other different address location. So let us assume that it is being pointed to some 3000 memory location. Okay, so at 3000 memory location, again it is creating something called as new account, and this is at 3000 location, and because of line number 26, okay, because of line number 26, an already existing variable account will now be pointing to a new memory location called 3000. Okay, again, this is not a concept of polymorphism. I'm just explaining some basic initial steps for your understanding. Is this clear? Because of line number 25, it is pointing to 2000, just for your understanding, and because of 26, it is pointing to some random address again. Maybe let us assume that it is 3000. Okay, that's good. Now, whatever I write at line number 28 is considered as a polymorphic behavior. See what I'm understand what I'm trying to write. I say account equal to new savings account. So what did I write? Before I explain line number 28, just reiterating the comments for line number 26. Okay, account is a reference variable of type account, well and good, and account is pointing to an account object in the memory. So for line number 26 also, whatever lines that I have highlighted at line number 23 and 24, they hold good exactly the same way. Is it clear to everyone? I'm just talking about line number 26 only at this context. Okay, so now taking the same old concept to line number 30. So taking the same old concept to line number 30. Account. What is this account type? Account is again a variable of type account. Okay, and don't confuse that. In polymorphism, don't think that you must maintain this name exactly equivalent to this name with a different case. It's not the scenario. You can say here as ABCD also. Just in order to make a meaningful name, I said account. Okay, now line number 28 holds good exactly the same way for line number 30, but the difference is at line number 29. Account is a reference variable of type account, and account is not pointing to an account object. It is pointing to a savings account object in the memory, which means at line number 30, by the time line number 30 comes, see how exactly JVM executes. JVM executes line number 17, then 21, then 25, then 26. So when JVM executes line number 25, it creates an account variable and it creates this object at 2000 location, and it points account points to 2000 location. When JVM completes line number 25 and executes line number 26, and once it completes line number 26, what happens? A new account object is created at line number 3 at some memory location 3000, and the old existing variable will point to 3000 location. And now if at line number 30, if it starts executing, when the JVM executes and completes line number 30, this is what happens. It creates a new object in the memory, and that new object is of type is of new savings account object, and the same old reference variable, which is nothing but an account, will be pointing to this location. Now it will no longer point to 2000 memory location. Now this will be gone, 3000 will be gone, and if suppose if new savings account is at location 4000, then the account reference variable will now be pointing to 4000 location in the memory. So because of line number 30, the same account variable will now be pointing to a different location called 4000. Now next, see the next statement that I'm trying to write at line number 34. I say account equal to new checkings account. So let me do one thing. I want every one of you to tell me is there any change that I need to make at line number 32 or 33? Any difference? Anything? 33. Very good. 33, instead of making a savings account, I need to make sure that it points to a checkings account object. Okay, very good thing. So all it does is, instead of this, it tries to point to a new object which is of type new checking account, and let us assume that this is at location 6000, and now the account object will be pointing to 1000 location, and this reference will be gone, and account object will now be pointing to checking account. Okay, so 6000. And one last scenario for the day, means in this context. So I say account equal to new special savings account. So any change at line number 37? Very good, very good. So one last diagram here in this context. So I say here new savings account, and if it is at line number 7000 at memory location 7000, then I say that account will now be pointing to 7000 location, and the references for 4000 will be it's gone long back. 6000 will be gone now, and account will be pointing to this 7000 location. Okay, now if you understand the concept clearly, the same variable account, okay, at line number 25 and 26, it is pointing to an account object. Okay, what is it? It is pointing to an account object, but the same variable at line number 30 is pointing to a different type of object, like a savings account object. At line number 34, it is pointing to checkings account object, and at line number 38, it is pointing to special savings account class object. Okay, so it means at different instances of time, a same variable is pointing to different objects in the memory. So that is nothing but a polymorphic feature that is being exhibited by a variable called ACCOUNT account, which is created at line number 25, which is of type account. Is this concept clear to everyone? The concept of polymorphism. Okay, is it easy? Is the concept of polymorphism? Yes. If you don't understand, it's one of the most confusing concepts. If you understand, it's one of the easiest concepts. Okay, now taking this polymorphic concept to the next level. Okay, so now see, the basic uh, understanding that you need to have in the concept of polymorphism is, on the left hand side, okay, on the left hand side, whatever type of object, okay, whatever type that you are writing here of class, that must be either equivalent to the right hand side, or the left hand side must always be the parent. Okay, so which means, like, I don't want to disturb the hierarchy here. let me create one more class. So here, when I have a savings account equal to, sorry, savings account s sa equal to new savings, which means both the left hand side and the right hand side of equal to symbol are on the same level of the hierarchy, which means it is of same thing, savings account. Either it can be this way, or you can say SA equal to new special savings account, which means on the left hand side this SA is of type savings account and this is of type special savings account, which means on the left hand side you can write a parent and on the right hand side you can write a child. That is what my intention is. So left hand side can be like account ACC equal to new account, or you can say account ACC1 equal to new savings account, or you can say account ACC3 equal to anything, new checkings account, like that, ACC3 or ACC33 or 34 or whatever, something equals savings. So left hand side must always be either the same level of right hand side or a bigger one. Okay, when I say level, don't consider the level literally. Why? Because so answer this question, can I write savings account SACC equal to new checkings account? Can I write that, yes or no? Very good. The answer is no. Why? Because if you want to exhibit, or if you want to make sure that a variable exhibits polymorphic behavior, then either it must be in the same hierarchy or they must be doing an inheritance with one another, which means this and this. If you see the relation between both of this, savings account is extending an account, checkings account is extending an account, so it has the hierarchy. Or if you say ACCOU account A5 equal to new special savings account. So special savings account, it might not extend account directly, but still this is extending savings account, which is again extending an account. So that is the reason why you can write this. Or you can write one more thing, savings account S6 equal to new special savings account, like this. Okay. So if you want to exhibit a polymorphic feature, then it means that the special anything on the right hand side must extend this savings account in the current scenario or in the current context. That's the scenario. Okay, so line number 17 is invalid, or there is no relationship between these two classes like savings account and checkings account. Clear till this point? Okay, and the last concept, and again the most important concept to understand for in today's class, it's like calling the methods. Now we will try to understand how we can call the methods. Most important thing. And the blind concept that I want every one of you to follow is compile time and run time. So when I'm writing a code, is it compile time or is it run time? So when I'm very good, when I'm trying to write the code in Eclipse, or when I'm basically writing the code, it means the compiler comes into effect and it tries to check if everything that I'm writing is good or not. So this is compile time. So I would like to explain two scenarios. One is compile time. Okay, compile time, and runtime. Left hand side of equals. This is for your maybe easy understanding purpose. Left hand side and right hand side. So the first time when I am writing a code at compile time, I want to call certain methods ACCOUNT account dot. When I say account dot, okay, so in account class, how many methods I have? In account class, I do have two methods, which is nothing but get account balance and get interest rate. So now when I go to test.java and say dot get account balance, it is from account class. Simple, well and good. ABCD 1 2 3 4 done. Then account dot get interested. This is from account class. At least line number 27 and 28 are straightforward scenarios. Nothing to think much. Why? Because it is present. It is of account is of type account class and it is pointing to account object. So 27 and 28 are simple scenarios. Let's understand from line number 33 onwards. Now this account object is pointing to new savings account. Okay. Now this is this special scenario. This is where you need to understand the left hand side and right hand side. The left hand side account, this is of what type? It is of type account. So always at compile time you need to think of the methods in the account class only. So you say account dot get account balance. So where is it being called? From the account class only. Understand here, from the account class only. AA11 and then account dot. This is one thing which might confuse you. Why? Because everyone understood that in the savings account, when I wrote get interest rate, the get interest rate is present in the savings account, which hides the parent class method is what I told. That's exactly the right thing. So many people think that account equal to new savings account. So when I say get interest rate, it must show savings account. That's what many people think. But the concept is it only shows account. I will explain this concept slowly. Okay. So to remember or to understand this concept in a better way, just follow the blind concept for time being. It means during compile time, the left hand side is considered or taken into account. What is left hand side? The left hand side account is of type account. So this class is only taken into account. Okay. Now let me put a breakpoint at line number 33. Execute the program and let me try to explain line number 33 and 34 in this context, not other lines. Only I am explaining line number 33 and 34. What happened? Okay. So the control is at line number 33. Now, are we in compile time or run time? What is this current scenario? Very good. Now we are in runtime scenario. We are running the program. Okay. So we are running the program. So we are in runtime scenario. In the runtime scenario, okay, as and when line number 32 is executed by the JVM, the object is created. Okay. Till line number 32 is executed, the object is never created for you. But as and when the control completes line number 32 execution, then account will point to new savings account object in the memory. So now since it is pointing to this object, that object is created, and in that object it will check, hey, is there a get account balance? No, it is not present. So which method will be called? It calls the account class get account balance method. So when I execute it, F6, it calls the account class get account balance method. Now when I execute line number 34, this is what is the most important thing that you need to understand. During the compile time, when I executed, this get interest rate shows that it is from the account class. This is what is being shown to you. But at runtime, if I execute this, just one thing, see, when I executed this, it did not call this get interest rate in account class. It called the method in the savings account. So understand the statement that I'm going to make now. The decision to call a method is taken at runtime. So at line number 34, during runtime, it thinks, hey, do I need to call an interest rate which is present in the account class or in the savings account class? Ideally, since after executing line number 32, since a savings account object is created and get interest rate is present in the savings account, only this method will be called. The account.java method will never be called during runtime for the scenario line number 34. Okay, so at compile time there are few things, and at runtime there are few things. So when you are trying to code, compile time, that is compile time, during compile time you need to take reference of this type. What is this account type? The account is of type account. So during compile time you need to take reference of the left hand side. And there is one more scenario that I want to add here. So I say public void uh, method 1. Okay, now see here, the method 1 is present in the savings account. Okay, now let me go back to demo.java. Okay, this is a different class team. Remember, this is a different class. So savings account as is equal to new savings account, right? So now using that variable SACC dot, when I say, I can see here method 1 which is present in savings account. Okay, well and good. Now if I try to do the same scenario in this test.java, if I try to do the same scenario in test.java, I cannot, or I can never ever call that at line number 35. Account dot method 1. I can never call method 1 here. Why? Because at compile time it will not take savings account into consideration. It will only take the right left hand side, which is nothing but the account, into consideration. So if you see here, account dot method 1 cannot be called in when you are trying to exhibit polymorphic behavior. Clear with this concept? Yeah, that's why, like, to understand that concept, like this concept, whatever I've explained. Yeah, I'm going to explain that, Ravi, right now. This concept is called as a runtime, or means dynamic binding or runtime binding. That is what it is called. Why? Because at compile time, when we understood the concept, at compile time the left hand side needs to be taken into consideration, at runtime, the right hand side needs to be taken into consideration, right? In this scenario, when I take the left hand side into consideration, I can never ever call method 1. But still, the advantage of this scenario is the polymorphism is the biggest advantage. Why? Because using a polymorphic feature, what you can do is, the first thing that you do is, we create a parent, and in that parent we can write down all the common features. Like, what are all the features that the child objects can exhibit? Like that, if you have 10 features, we exhibit all the we write all the 10 features in at one common place in the hierarchy. So if I write all the 10 things at a hierarchy, then in test.java or in any other class, what you can do is, you can just create one reference variable account, and using this account reference variable, you can create or you can point that reference variable to n number of objects out there. So let us assume that at line number 25, you are creating a reference variable. At line number 26, you are creating a new reference variable. Or at, see here, or maybe take this example. At line number 11, as and when this line is executed, you are not using ACC at any other location, right? Which means you are creating this object, using it, and the use is done after line number 11. And like this, if you are creating multiple objects, it means you are unnecessarily creating multiple objects and making more objects to be garbage collected every time. But here you are reusing the parent variable every time, instead of creating a new reference variable, which means you are not creating so much garbage, and you are trying to create a concept of polymorphism, where all the features must be defined at one location. Like, means in the concept of inheritance, what you are trying to do is, you are trying to define all the features at one location, and using the parent class reference variable, you can point to any children and give the same features. Maybe what I will do is, like, uh, uh, we means if I start the next concept, the next level, you will understand the real use of this variable, like polymorphic variable, where I create a method and try to pass this as the input. Then you will understand the real concept, but maybe time might not permit, like it might take a longer time. So for now, just understand that this is a concept where you can use a parent class reference variable to point to either the parent class object or to any of the child class objects. And when you are pointing that way, you can use to call the methods. So when you want to call a method, always at compile time, check what is the reference variable of type. So it is of type account. So you can call all the methods of the account. But at runtime, if it is pointing to savings account, then check if any of the methods are present in the savings account. If so, you can call the methods in the savings account. If not, it goes to the parent class. Okay, that's the concept. So any doubts or any questions in this concept till now? Okay, that's good. So if it's no, like, I'm just stopping the recording.